In this tutorial, we will build a incoherent feed-forward network by using biological parts such as promoters, RBS, coding segments. So let's select a promoter from our catalog of parts. So that's a promoter. Let's select a RBS, and a coding segment. Notice if these components are not in this list, they will be in this complete parts list. Now let's connect these together, and now let's insert a protein that's being generated from the coding segment. So right click and then insert gene product, and then I'm going to move this for visual appeal, and now I'm going to select this entire segment, copy and paste to duplicate the entire the small regulatory network. Let's insert a terminator also, terminator 1, terminator 2, and then put that there. Move these here, connect the entire segment together, and now to construct the incoherent feed forward, we need a inducer molecule S1. The inducer molecule upregulates promoter P1 and promoter P2. So notice I selected the transcription activation reaction. And the protein P1 will downregulate P2, or downregulate the promoter P2. So I'm going to select transcription repression from P1 to promoter P2. Now let's check the rates that have been automatically derived when we make these connections. So if I double click on P2, a transcription rate has already been generated automatically based on these connections. Similarly for P1. And the translation rate, you can notice it has been adjusted to P2.rate. Now if you adjust these RBS once more, you will notice that the translation rate has also been adjusted to include the RBS strength for both proteins. So both proteins contain a transcription rate and a translation rate, which is dependent on the promoter and the RBS respectively. And now let's see if this network actually produces the behavior that we want. So we'll do a steady state analysis involving S1. So the steady state analysis involving S1 looks like that, which is not the behavior we want. We want a shape that goes up and then down. So S1 is an activator at low concentrations and an inhibitor at high concentrations. Actually, to do this, from a previous demo we saw that we just need to adjust the dissociation constants here and here. And then let's adjust some other things such as the promoter strengths. The promoter strength, let's increase that to 5. And let's see if that produces the behavior we need. And that is the typical behavior of a incoherent feed-forward network.